So for what we have here, okay, now for a conditional, now a conditional is going to be, for our purposes here, conditional is going to be an equation with a limited number of solutions. It could be one solution, two solutions, but as long as you have like a finite number of solutions. And we can say that, for example, if you're looking at solving for x, and we'll go with something fairly basic. Okay, we'll say we have something like 2x plus 5 is equal to 17. Okay. So if I'm looking at solving for x, okay, what I'm going to do here is I want to get the x term by itself and take care of any residing coefficients. So I have a single x term on the left, okay, and to get the left-hand side in terms of x only, I'm going to have to take care of the 2 as well as the 5, and so I can initiate the process by taking away 5 from both ends. So left-hand side we have a 2x, and to the right we have 17 minus 5, which will be at 12. And then undoing the multiplication by 2 by dividing both sides by 2. It's going to follow that for 2x over 2. Okay, this comes out to the desired x, and 12 divided by 2 is 6. So you have a limited number of solutions with only one solution, with that at x is equal to 6. Okay, so this again is a case of a conditional. So you would have that 2x plus 5 is equal to 7 to ring true on the condition that x is equal to 6. Now, in the next category where we have a contradiction. Now, a contradiction is going to be an equation that has no logical solution. Okay, so you're trying to avoid inconsistencies. Okay, and let's say that if you're looking at, let's say, once again, trying to solve for x, and we'll say that we have 2 times, okay, the quantity of x plus 3. And say we have minus 4 is equal to x plus x minus 5. Okay, so you're looking at the value or values of x, okay, where both sides of the equation will be equal. Now, if I take care of, first of all, the parentheses on the left, so distributing 2 all over the quantity of x plus 3, I'm going to have 2x plus 6, and we have minus 4, and we have with x plus x minus 5, x plus x becomes 2x, we have minus 5, and then we have 2x once again on the left, and plus 6 minus 4 is going to be plus 2. And again, we still have 2x minus 5. And if you notice, we have the same weight in terms of the variable terms on both sides. And if I join them together, so if I subtract 2x, let's say on both sides, so you have complete cancellation, and left standing will be two numbers that are said to equal each other when in fact they are not. Okay, so there's nothing in x that we can do to rectify the situation. Okay, we did the correct algebra, and the variable terms wound up canceling each other out, and left standing are numbers said to be equal to each other when in fact they are not. And so we have, in effect, since there's nothing in x, positive, negative, or 0, that can make both sides of this equation equal to each other. So in effect, okay, we have no solution. And again, this is a case of a contradiction. Okay, so conditional has a limited number of solutions. Contradiction has no logical solution. Now, for an equation that results as an identity, okay, so an identity will be an equation that has an infinite number of solutions. And we'll say that we have, for instance, okay, something that can lead up to an identity. And say we have solving for x. And we'll say that we have 3 times the quantity of x plus 4. And we have is equal to x plus 6. And we have 2 times the quantity of x plus 3. Okay. So for what we have here on the left, so we have 3 times the quantity of x plus 4. So we have equal to x plus 12. And then we have to the right, we have x plus 6. And distributing 2 over the quantity of x plus 3, okay, we have 2x plus 6. Again, we have 3x plus 12, and to the right we have x plus 2x, which will make 3x. We have plus 6, so this will be plus 12. And if you notice, okay, we have same terms on both sides. And if we were to unite the variable terms, they're going to end up canceling each other out. And for what is going to remain will be 12 on each side. So you have 12 is equal to 12. Now we have 2 numbers that are said to be equal to each other. In this case, that statement is going to be true. And what this is going to signify is that you have x, it could be 0, it could be a positive value, or it could be a negative value. And anything you plug in for x, you're always going to have both sides to end up equaling each other. And so we're going to have an infinite number of solutions. And the way you can express this, you can say we have all real numbers. Or you can also symbolically write, okay, with just the capital R in reference to all real numbers. And probably the most common notation we'll be looking into will be interval notation. And it'll be just like those numbers running between negative and positive infinity. So these are three different ways of saying the exact same thing. So we're just looking at referencing all real numbers like positive numbers, negative numbers, zero, fractions, radicals, reducible fractions, irreducible fractions, that sort of stuff. And so again, this is going to be yet another case of what we have with an identity. Okay. Now, in the case of equations, now the ones we looked into were first degree in the variable x. Now, looking at sort of tying in what we have had with factoring and the FOIL method, looking into second degree equations, and we have in the next realm, okay, we have for quadratic equations, now for a quadratic equation, and we have by definition now a quadratic equation is going to be a second degree equation whose standard form again, whose standard form, okay, we're going to have it ax squared plus bx plus c is equal to 0, okay, whereupon a does not equal to 0. And what I mean by second degree equation, and again, we have just for the variable of concern, the independent variable we have at x, so second degree is in reference to the power 2. And if we had a equal to 0, this term would vanish and you would no longer have a second degree equation. Now, for quadratic equations, okay, there are various techniques that can be utilized, just given the type of coefficients involved. And we have one common approach is going to be the zero product property. And this property states that if we have at least two expressions, again, not limited to two expressions, but say we had two expressions, a and b, and they multiply out to 0. For this to be true, then at least one of these factors has to be 0. So for the product to be equal to 0, in other words, for a times b to be equal to 0, one of these must be 0. And in terms of what this has in terms of the quadratic equations, in other words, what's this got to do with the quadratic equation? And we can take just as examples here, and we can say that in solving for x, And we'll say that we have let's say we have x squared plus 7x plus 12 is equal to 0. And just looking at what we have here, so you're looking at the values of x such that x squared plus 7x plus 12 is equal to 0. And if we look at factoring, so from x squared we have x and x. Now for factors of 12, that will add up to 7. So you have plus 4 and plus 3. And you might be wondering, okay, where did I see this before? This is back when we were looking into the restricted values. Okay, so this in a way was the zero product property, but we were looking at what was disallowed in x from being equal to 0, and also what was disallowed in y from being equal to 0 from those first two problems. But now we're looking at solving, okay, upon setting equal to 0. So we have if x plus 4 is a 0 factor, we have x plus 4 is equal to 0, and from this, okay, we'll have x equal to negative 4. And if, on the other hand, we have that x plus 3 is equal to 0, we're going to have that x is equal to negative 3. And you can always go back and check your solutions. We have negative 4. Now, if we have x at negative 4 squared is going to be a positive 16. 7 times negative 4 is a negative 28. So you got 16 plus negative 28 will be negative 12. Negative 12 plus 12 is 0. Now for negative 3 squared is 9. Now we have 7 times negative 3 is negative 21. 9 minus 21 is negative 12. And in turn, negative 12 plus 12 is equal to 0. Okay. And so we have, again, this is another case of a conditional where this equation is true on the condition that x is either negative 4 or negative 3. And let's say that we have as a second case. And let's say we have an equation that is quadratic, but it is not yet in standard form. And we'll say that we have for this one. Okay, let me say that we have x squared plus 36 is equal to 12x. Again, you're looking at the values of x such that x squared plus 36 is equal to 12 times x. Now, if you notice, this equation is not set up in standard form. That is where it is equal to 0. But we can make a quick fix of this. Now, the highest degree term is x squared, which is on the left. And what we can do is that we can form a trinomial in descending degree order if we just move the 12x over. And we're going to have in the rewrite, okay, so we're going to have x squared minus 12x plus 36 is equal to 0. And looking at factoring, from x squared I have x and x. And then factors positive 36, that will add it to negative 12. Well, guess what? It turns out that this is a squared trinomial, since we had the same binomials factored out with x minus 6 and itself. So you're going to have, in the result, you have a repeating factor. So we have only one x factor to result. And if we set this to 0, it's going to follow that we have x is equal to 6. And checking out, 6 squared is 36 plus 36 is 72. And simultaneously, 12 times 6 is 72. And 6 will be the only solution that will cause this equation to ring true. Right. And so just one more case here, and just want to mention in terms of how to go about, let's say if you have an additional coefficient, and let's say that if we have so you have negative 2x squared plus 8x plus 64 is equal to 0. One approach, say if I want to work with just x squared, I can factor out the negative 2. So we have negative 2 into negative 2x squared, so this will be x squared. Negative 2 into 8x, so this will be a minus 4x. And negative 2 into positive 64, that's going to be a negative 32. And we have negative 2, and we have with the trinomial resulting in the reduction. So x squared, we have x times x, and factors negative 32 that will add up to minus 4. Okay, more weight is going to be given to the subtraction than to the addition. So you have x plus 4 and x minus 8. And in terms of our x factors, now negative 2 is just like the filler. It's not doing anything with x in terms of the basic operations. It's not adding, subtracting, multiplying, or dividing x. So this is just kind of like a dummy factor. It's not doing anything for us in terms of solving for x. But last two expressions, okay, we do have an x. So we have x plus 4 is equal to 0. We also have x minus 8 is equal to 0. And if x plus 4 is equal to 0, so we have x equal to negative 4. And for x minus 8 equal to 0, we have the x is equal to 8. And you can always go back and check, and those will be the solutions. And I'm just going to mention, I'll just give a slight reworking of this. Just creating a very slightly different pathway. Say if I were to just divide by the leading coefficient, negative 2. So if I divide the equation by negative 2, what's going to happen here is that we would have x squared minus 4x minus 32 is equal to 0. And you'll still have the same binomial factors. And once again, just setting each of these equal to 0. You still have x at negative 4 and also x at positive 8. And both approaches are viable. And you still get the same result.